here we go on Hawk section 7.3. And the first thing that we're going to take a look at are some graphs of log functions. And so the first one is going to be f of x equals log base 1/2 of x. And we're going to do our tricks here, okay? We're going to say, well, that the base is 1/2 and 1/2 is less than 1, so we know it's a decreasing. We know that the x-intercept is 1, 0. There are no other transformations, so no transformations. So now we're ready to just graph this thing. And so we go over to 1, 0, and we put our point, and since we know it's decreasing, we know it's going to look something like this. And that's it, we're done. Right, 2. We'll have f of x equals log base 1/4 of let's see, hold on, let me back it up. Log base 1/4 of x minus 3. And so we'll say, okay, that the base is 1/4, which is less than 1, so we know it's decreasing. We also know that the x-intercept is 1, 0. Now, here's a transformation. This is telling me that I need to go right 3. And so if I go right 3, then the 0.10 is going to turn in to the 0.40. And so this is going to be the point with which through which I draw my line. So 1, 2, 3, 4. Since there are no other transformations, and since I know it should be decreasing, it's just going to look something like this. Okay, next. Number 3. We'll have, whoops, well, not that at all. F of x equals log base 1/2 of x plus 3. And so we're going to say, okay, well, the base is 1/2, that's less than 1, so it's decreasing. We also know that its x-intercept is 1, 0. And we know that this guy, this big plus 3, means that we're going up 3. So if we start at the 0.10 and we go up 3, then the 0.10 will turn into, oh, hold on a second, back it up. The 0.10 will turn into the 0.13. And so since there are no other transformations, this is the point that I'm going to draw my line through. And so I go over 1 and I go up 3. And so here's the point. And since I know this is a decreasing function, it's going to look something like this. Okay, that's it. All right, now, as far as the graphs go, this is just about as much information as I need from you because, again, in Hawks, they're going to ask you to choose from a graph. And so your main concern in Hawks is going to be, where's my new point? All right, so now we're ready to actually talk about logs themselves, meaning starting with something and turning it into starting with a log and turning it into an exponential function and vice versa. So let's say that the problem is log base x of 162 and that equals 6. And this is this is a log form. I need you to put it in exponential form. So we're going from log to expo. And as we discussed in our notes, we're going to draw these arrows a lot. And so all we're going to have to do is say, oh, well, this is this is x to the 6th equals 162. And right now, I don't want us to solve. I just want us to rewrite it because we got to get the hang of rewriting it down first. So I guess this was, I don't know, I guess this was number 4. Okay, and so I went from log to expo, and now I'm done. And so now on number 5, in addition to actually rewriting the problem, we're also going to evaluate it. So the problem is log base 6 of 36 equals y. And so again, the first thing that I want to do is to draw my arrows, and then I want to rewrite this. So I got to go from log to expo, and then I want to also solve. And so this is going to become 6 to the y equals 36. And so my question is, 6 to the what gives me 36? And you can do this one of two ways. You can just know that 6 squared is 36, or you can do what we did the other day and say, this is 6 squared, and this stays 6y, and so because of that, y equals 2. Either way. But the point is, when you evaluate this, y is equal to 2, and now we're done. All right, let's try a couple more here. Number 7. Let's say that I have log base 1/9 of 81, and that is equal to y. And so again, I'm going to draw my arrows in here and rewrite this thing from, let's see, I'm going from log to expo, and then I'm going to want to solve it. Okay, so this is going to become 1/9 to the y, 1/9 to the y equals 81. Come on, equals 81. I'm going to say, okay, well, it'd be super great if these have the same bases. They don't, but I can probably somehow make them have that. And so what I want to do is I want to say, well, I know that the number 1/9 is really 9 to the negative 1. And that's still being raised to y. And I know that 81 is really 9 squared. And so now I have these exponents, and I'm going to set them equal to each other. So what I'm going to have is negative 1y, or just negative y, equals the number 2. And then, of course, I'm going to have to divide both sides by that negative 1. And so that's going to give me y equals negative 2. And now I'm done. All right, next, number 8. Let's say that I have log base 3 of 1, and that is equal to y. Well, again, I need to draw in my arrows. We're doing this every time. And here we know that we're going from log to expo, and then we're going to solve. And so this becomes 3 to the y equals 1. Now, this is one of those things that we just have to know. We know that anytime you have a number that's not 0, and you raise it to this particular power, it's going to give me 1. And in this case, that power is 0. And so this is one of those things that you're just going to have to memorize. Any number raised to the 0 is going to give me 1. So my answer is 0. Now I'm done. Okay, number 9. Let's see. Let's say, okay, now we talked about the natural log and the common log in our notes. So let's say that we have the ln of the 8th root of e to the 6th. Now we got to step over here for one moment, and we talked a long time ago about how when we have an exponent that is a fraction, it really means a radical, okay? And we put the number that's on top on the inside and the number that's on the bottom on the outside. And so we're going to rewrite this as the ln of e, and we're going to take this radical and we're going to turn it into a fraction. And so the number 8, since it's on the outside, it's going to go on the bottom, and the number 6, since it's on the inside, is going on the top. All right, now we can see that this fraction can be simplified. We're going to simplify that to 3/4. And so what's going to happen is when we take the ln of e, we know that that's just the number 1. Okay, so we know that the ln is also log base e. So we're changing ln to log base e of e to the 3/4 equals y. And so now I can draw my arrows in. And when I rewrite this, I'm going to have e to the y equals e to the 3/4. Well, in this case, since I already have the same base, I know that y is equal to 3/4, and now I'm done. Okay, number 10. Let's have log base 32 of x equals 4/5. So first things first, I draw my arrows. And then I say, okay, that means 32 to the 4/5 equals x. Now, my best advice is to just type this into the calculator. Okay, but let's say, maybe when you do type that in, make sure though that, and I need to fix this, make sure that when you type this in, your exponent is actually an exponent. And so if you were to type this in to the calculator, you're going to get that x equals 16. So this one is a calculator problem. Okay, some of them you will definitely need your calculator, and some of them you will not. Okay, all right, so we're done. So 11. Okay, now this one we're going to change it up a little bit. We're going to be given this problem, which is clearly expo. We want to turn it into a log. We're not going to solve it, we're just going to transform it. And so again, the first thing we have to do is to draw our arrows. And so we're going to rewrite this as log, our base is y, so log base y. We zoom over to the 4.4, and that's equal to 5. So my answer here is log base y of 4.4 equals 5. And the instructions will tell you whether you're evaluating or whether you're just changing things, so pay close attention to those. Okay, now, number 12 is going to look a little different, but we have had some, this was in our notes, okay, and so this might be the first time you've seen one, but it's 7, it's the number 7, and the exponent is actually log base 4 of x, and that's equal to 49. So technically, this is an exponential function. Okay, so if we could turn it into log, that's going to let us solve it much easier. And so the first thing I want to do is draw my arrows. And even though this exponent is a whole big nasty thing, that's okay. So we're going to say, see, how am I going to write this? we're going to say, to write this as a log, we're going to say log base 7 of 49 equals, and then this big old nasty thing, log base 4 of x. And so now what we're going to have to do is do each of these little guys separately, okay, because something magical is going to happen over here on the left-hand side. So if I could just insert a teeny tiny equals y, and I could draw my arrows again and say, oh, well, 7 to the y equals 49. In this case, y must be 2. So then if I come over here and I say, well, if y is 2, then I'm looking at just this side. I'm going to say that log base 4 of x must equal y, which again, I just calculated to be 2. So let me get that out of there. And let's put a 2 here instead. So now we're focusing on this, okay? And so we're going to draw our arrows. We're going to say, oh, well, that means 4 squared is equal to x. Well, 4 squared is just 16. And so x is 16. And so sometimes we're going to be given problems that have pieces that look like this. And hopefully you're going to recognize some of these. And anytime the base, and anytime we can get rid of the base by actually evaluating one side, that's exactly what we want to do. Okay, so that one's a little different. You will see those again. And again, we did see one in our notes, but this is probably the first time you've come across it. Okay, next, 13. The problem is log, and then there's a parenthesis, and then 0.0001. Okay, and that's what they give you. And they're going to say, without a calculator, they want you to solve or evaluate. Okay, and so we need a final answer as a number. And so what we're going to do is say, okay, well, when we just have regular old log, we know that's base 10. And if we read this, if you remember how to read a decimal, this says that this is the tenths, this is the hundredths, this is the thousandths, and this is the 10,000ths. Okay, and so what we're going to do is we're going to rewrite this. And since it's, on the right hand side of the decimal, we know it's an actual fraction. It's not the number 10,000. So we're going to write this as 1 over 10,000. And this fraction that we've just written, this is the number, let me fix it, I got a little messy. This is the number 1 over 10,000, which is equivalent to this. And then we're going to slap an equals y on there, and we're going to draw our arrows. And we're going to say, okay, well, 10 to the y equals 1 over 10,000. Okay, and so now what's going to have to happen is we're trying to figure out 10 to what number gives me that. Well, if I just step over here for a moment and I just look at this little guy, so let me do this in orange. If I just look at 1 over 10,000, I need to somehow turn that into a base 10 because this 10y isn't going to change. And so I say, okay, well, that's 1 over 10. 10 to the what is going to give me this 10,000. Let's count our zeros. 1, 2, 3, 4. So this is 10 to the 4th. 1 over 10 to the 4th. However, we don't want a fraction, so we know if we have to move that 10 to the 4th up, it's going to become 10 to the negative 4th. So this number is actually 10 to the negative 4th. And so now that I have the same bases, it's very easy for me to say, oh, y is equal to negative 4. And again, I don't need and I can't use a calculator for this. Okay, and the instructions will be clear as to when you can and when you cannot use one. Okay, so there's 13. All right, so let's see here for number 14. All right, so the problem is going to be log of 8x equals 2.8. And I'm trying to solve this. Okay, so I want to solve. So I'm going to go, actually, you know what? Let me get rid of that. Let's write our plan. Clearly, this is a log. I'd like to rewrite it as an exponential, and then I want to solve it. And so the first thing I'll do is I'll draw my arrows. Actually, that's a lie. The first thing I'm going to do is say, hey, you know what? Since there's no base given to me right here, I know that it's actually 10. It's the common log. Now I can draw my arrows. So from 10 to 2.8 to 8 to 8x. And so when I rewrite this, I'm going to have 10 to the 2.8 equals 8x. Okay, well, I don't really know or care right now what 10 to the 2.8 is. The point I'm trying to make here is I need to get this x by itself. So it's being multiplied by 8, so I'm going to divide. So that's going to give me x equals 10 to the 2.8 divided by 8. Type this in, okay? And then you're going to say x is approximately. Now, before I actually write the answer, I want to warn you about something. Type this in first, 10 to the 2.8, hit enter, and then type divided by 8 and hit enter again, okay, so that your calculator reads it the right way. Okay, and so when we type this in, and it's going to tell you how many decimal points to round it to. In this case, it's just 2 of them. And so we're going to get x is 78.87. Okay, and so we will use a calculator on some of these. All right, done. Okay, let's see. Number 15. Hold on 1 second here. Number 15. All right, so we're going to have log base 2 of 4 to the 5x equals 6. And so this is log. We want it to turn it into expo, and then we want to solve. And so we'll draw our arrows from base 2 to 6, and then to the 4 to the 5x. We'll say, okay, well, 2 to the 6 equals 4 to the 5x. Now, this is one of the problems that we had similar to the other day, where we want the same base. Well, we have a base 2 right here. Let's turn this 4 into base 2. We know that 4 is just 2 squared. Well, we also know that the 5x still exists. And so we're going to take these little guys, and we're going to set them equal to each other. And so we will have 6 equals 2 times 5x. And then when I do that, I'm going to get 6 equals what? 10x. And then I will divide both sides by 10. And that'll give me x equals 6/10. But of course, I want to reduce if I can. And in this case, when I do that, I'm going to get x is 3/5. And now I'm done. All right, next up, 16. The problem is the ln of 4x plus 4 equals 2. And so what we're going to do, clearly this is a log problem. I want an expo problem, and then I want to solve. So the first thing that I need to do is say, hey, look, I'm talking about the natural log, which I know is log base e. And of course, for right now, this stuff hasn't changed. I've just changed the bases so that I can draw my arrows. When I do that, I'm going to get e squared equals 4x plus 4. Now, for the time being, I don't care what e squared is. My goal is to get x alone. So I'm going to subtract 4 from both sides. I'm going to get e squared minus 4 equals 4x. And then I'm going to divide both sides by 4. And so I'm going to get x equals e squared minus 4 over 4. This is my exact answer. Hawks will ask you on this particular question for an exact answer. And then it's going to say, also give me a decimal approximation. And so now what you're going to do is you're going to type this in. Here's how you're going to do it. Type this part in first, then hit enter, then hit divide by 4, and then hit enter again. Okay, don't just try to type it all in at once, because what will happen is the calculator will read the operations incorrectly, and it will do this division, and then it's going to give you the wrong answer, and you're not going to realize it. Okay, so when you type it in correctly, and you're going to round it off to however many decimal points it asks. In this case, it's just 2. And so here's my approximation, and here's my exact answer. And again, Hawks is going to ask you for both of these, as will I when you take the test. All right, just a few more to go. Okay, number 17. We'll start with log base 8 of 2x minus 8, and that equals 2. And again, obviously this is log. We want to go from log to expo so that we can solve it. And so I will draw my arrows from base 8 to 2 to the stuff inside the parentheses. And when I rewrite this, I will get x squared equals 2x minus 8. And so 8 squared is just 64. 2x minus 8 remains. I'm going to add 8 to both sides, and that's going to give me, what, 72 equals 2x. I will divide both sides by 2, and I will get that x is 36, and now I'm done. Okay, last one, number 18. The problem is log base 2 of 7x equals 5. And so obviously this is log. I want to go from log to expo, and then I want to solve. And so I will draw my arrows, and when I rewrite this, it'll give me 2 to the 5th equals 7x. Well, 2 to the 5th is going to be the number 32, and that's equal to 7x, and I divide both sides by 7, and I get x equals 32/7. In this particular instance, this fraction does not simplify, and so that is my final answer. And now I'm completely done with this section.